Hello again, all of you cyber calculus students. This will be the culminating video in our combinatorics work. This video will contain a few examples of just several variety of types of questions, not obviously all of the questions that could possibly be asked, but just a basic introduction to them. So as we look at these examples here, you see 4 different ones talking about arrangement and choices. So what I suggest you do now is pause the video for a few minutes while you take your time to try these examples, and then after that restart it, and I will continue with kind of my way of doing the solutions to all of these problems. So go ahead and pause now. All right, well, hopefully you got a chance to pause the video and had a chance to start it up again. You were able to look at all 4 of these examples and see how you're able to do. So we're going to work through those now and kind of come back and forth. So as we look at example number 1, that question was about the word integral and asking how many different ways there are to arrange those letters. It doesn't say it has to make a word, just says it has to. We have to arrange those letters. So as we count up the letters, there are 8 of them. So there are 8 letters, and they are all distinct. That is key for us here when we consider, how many different types there are, how many different ways there are to arrange. And so since they're all distinct, and there are 8 of them, the arrangements should be pretty straightforward. It's going to be 8 factorial, which if you do that on your calculator is 40,320 different arrangements. So that's number 1. So as we look back at what number 2 was, number 2 was how many ways can a subcommittee of 5 be chosen from a class of 32? So as we come back here, so this is number 2. So you have 32 total students, and we want to choose 5. It's like, okay, well, if I have a total of 32 and I'm only choosing a subgroup of them, your question is then to determine whether this is a permutation or a combination. Is it a permutation or combination? And the difference is whether or not the order matters. Now this just said a subgroup, so it doesn't say that order matters, or anybody's the captain or anything like that. So it is key to note that order does not matter. If that's the case, this is a combination problem, and we just have to say, all right, you have 32n, your total number is 32, and we're going to choose 5 of those. And if you recall how to do that on your calculator, I'll do that one more time. If you go into your math program, you remember that that's where the C and P is, but remember we have to enter 32 first, the N. You go into your math button, over to your probability, and you see 2 and 3 is the P and C. So this is a combination, so we're going to use NCR, and we're going to choose 5. It automatically does all the calculation for us, and so apparently there are 201,376 different combinations. Now, recall, of course, that this calculator program does that nicely for us, but if the order does not matter, remember that that's a total of 32 factorial, all divided by 5 factorial times what would be then 27 factorial. 32 minus 5. 5 factorial comes from the fact that the order does not matter, so those are all the arrangements of those 5. Moving on to number 3. If we look at number 3, it says a menu has 3 salads, 2 entrees, and 4 desserts. How many different meals can be created? We're going to assume that you only choose 1 salad, 1 entree, and 1 dessert. Some restaurants kind of do this for lunch menus, stuff like that. So as we look at this is going to be the important information here is that you're choosing 1 of the 3 salads, 2 of the main entrees, and 4 of the desserts. And whether you choose 1 salad versus the entree is independent of each other. So this goes back to one of those first videos. And this is just your multiplication principle. And I'll just kind of quickly review what's going on. I mean, if I call my salads A, B, and C, from there you have two different options. I'll just call them M and N for no particular reason. You have two different options for your entrees, and from there you have four different desserts. Not desert, dessert. And so as you make your tree diagram here, remember a tree diagram can be used during your multiplication principle, which of course is just 3 times 2 times 4, which is a total of 24 different meals that can be created. So independence is key for that question. And then moving on to the fourth and final quick example problem. And so it says, 8 people are running in the Olympic finals of the 100-meter dash. How many different arrangements can be seen on the awards platform? So 100-meter dash, 8 people, awards platform. And so we just kind of assume that you know that that means that there are going to be 3 different positions. So you have 8 people running. You have 3 different positions that you're going to fill. And I think you could argue easily that the order does matter here, first, second, or third. And so then, since the order does matter, this becomes a permutation. So with your permutation, that is going to be 8p3, which, again, we can go into our calculator. And so if you go into the, first of all, of course, hit 8. See, it's my hard thing for me to remember is to hit 8 first, your n, and then you go into your probability, choose number 2, the p. It is a permutation, and we're choosing 3 out of there, so there are 336 different arrangements of people on the platform. And the formula without your calculator is going to be 8 factorial divided by 5 factorial, where 5 factorial comes from 8 minus 3. So those are just 4 quick example problems to kind of get you started. Obviously, the complexity of problems can increase greatly once you start to other probabilities, etc. And understanding what the total number of combinations is extremely important as we do start to talk about probability. Because in order to ask, you know, how many different ways are there for one person to get first, you have to know how many ways there are to get, you know, total as well. You know, so the total number of combinations is extremely important for probability, which is why we cover it now. So hopefully you learned a little bit from these videos, and we'll see how things go in the future.